So now let's say that we are in standard form and we have an equation like f of x equals x cubed plus 7x squared plus 12x. And what we want to do is we want to be able to solve this equation. So for this equation, what I'm going to look at, the first thought would be, oh, okay, I'll start making my list because it's not already factored. So I'm going to go try to make a list using my rational root theorem. So remember, the rational root theorem says that I'm going to take the leading coefficient, which in this case would be a 1, and the constant. Wait a second, there is no constant. So this right here tells me that I cannot use the rational root theorem. I need to just try to factor this equation. So remember, we looked at factoring a while back. Factoring in this scenario, I'm going to look at the three terms and I notice that they all have an x. So I'm going to factor this first with a GCF. So I'm going to factor out that x. Now, the idea is to get this completely factored. Okay, well, x squared plus 7x plus 12 is not all the way factored. I either have standard form or I have factored form. So since I've gone with factored form, I need to continue to factor. So now I'm going to continue to factor this x squared plus 7x plus 12. So factoring that, I would say, well, what multiplies to 12 and adds to 7? Well, it's going to be 3 and 4. So I have x times x plus 4 times x plus 3. Remember the x from the original GCF, and then my x plus 4 and x plus 3 from my remaining quadratic. Now that it is completely factored, I'm going to set each of those factors equal to 0. So I'll say x is equal to 0, x plus 4 is equal to 0, and x plus 3 is equal to 0. All right, so I'd solve these here. Solve this one. So I found 3 solutions. The question is, does anything repeat? Well, I'm not sure. Let's go back and see how many I'm supposed to have. So we go back to the very highest exponent. I don't need to count any of them up this time because I only had to count up when it was in factored form. The leading coefficient test tells me that I don't need to factor it, I don't need to count them up if I'm not in factored form. So the highest exponent is a 3, which means that I should have 3 possible solutions, and I found them. I found all 3. X is 0, x is negative 4, and x is negative 3. Okay. So we're going to look at one more of these that is in standard form. So let's try one more so we can go through all of the possible steps that we might need to take. So let's say we have f of x is equal to 4x cubed minus 8x squared minus 9x plus 18. All right, so I look at this equation and I notice it is not in factored form. So I'm thinking to myself, okay, well, I'm going to go and I'm going to make my list. So I'm going to try to first make a list of numbers that I could go try to see if they are solutions. So doing that, I'm going to use that rational root theorem. I'm going to take my leading coefficient and my constant, and I have both, so that's good. So making that list, and I'm just going to call that list R. Okay, so I'm going to have numbers that multiply to 18, so that's going to be 1 and 18, 2 and 9, 3 and 6. Then I'm going to have numbers that multiply to 4, 1 and 4 and 2. Remember, I don't need to write 2 down again. So now I'm actually going to divide those numbers. And when I go to divide those numbers, what I'm going to get, I'm going to get plus and minus 1, plus and minus 1/4. Remember, I'm just taking my number and dividing by each in the denominator. Plus and minus 1/2, plus and minus 18, plus and minus 18 divided by 4, which is going to be 9/2, plus and minus 9. Cross these off that I've used them. Plus and minus 2. Plus and minus 1/2, it's already on there. Plus and minus 1, it's already on there. Now let's go to our 9. 9/1, it's on there. 9 over 4 is not on there, so I'm going to add that one. 9 over 2, it's on there, so I'm done with that. Now I go to my next one, plus and minus 3. 3 over 4, it's not on there, I'm going to add it. 3 over 2, not on there, so I'm going to add it. Now I'll go to 6, plus and minus 6. Let's add that one. 6 over 4 reduces to 3 over 2. I've already got it. 6 over 2 reduces to 3, and I've already got it. So this is actually the list of numbers that I'm going to try. So we want to try these by either using synthetic division, or we want to evaluate these, right? Plug them into our equation. And the idea is that we're looking for which one of these gives us a remainder of 0. So which ones give remainder of 0. Now, the question is, well, how many of these am I even looking for? So remember, we're going to go back to our leading coefficient test. So I'm going to grab the highest exponent. So the highest exponent says that I'm going to have 3 possible solutions. So now I'm thinking to myself, okay, out of all of these, I need to find 3. The reason I want to know how many I'm looking for is because what if the first 3 that I try work? I don't want to go through the rest of the list, right? I'm only looking for 3 of these to work. Okay, so I can either use synthetic division, or I can evaluate with these, all right? So I'm just going to do a couple here. And let's say that I decide to just try off my first one, and we're going to use synthetic division. Who knows, okay? So let's say I'm going to try positive 1, and I'm going to use 4, negative 8, negative 9, and 18. So I bring down my 4. And remember, all I really care about is this last number, and I'm looking for 0. So the question is that going to be 0? So I'm going to start, I'm going to multiply and add. Multiply and add. Multiply and add. Nope, this one does not work. So I could cross positive 1 off of my list, right? I'm going to continue to do this until I found 3 answers that work, all right? So I'm going to show you one that does work since I know what the answers are here. All right, so let's say that we wanted to try the number 2. All right, so I'm going to plug in 2 for synthetic division. And let's try it. So I bring down that 4. 4 times 2 is 8. Bring that down, I get a 0. Or add that down, excuse me. 0 here, negative 9, negative 18, 0. There we go. Now we've got a remainder of 0. So that means that 2 is indeed a solution, right? So I need to do this until I have 3 solutions. All right, so let's say that we also tried, and this time we got tired of synthetic division, so we wanted to plug in a number. Let's say that we tried 3 halves. Okay, so I'm going to plug in 3 halves. Right now we're using that idea of my remainder rule that says I can either do synthetic division or I can evaluate. And when I plug this in, I will end up getting 0. So again, we've got another remainder of 0, which means that the answer 3 over 2 is also a solution, okay? So I can do either of these, and I'm looking for 3 solutions, right? The last solution that we would find, again, let's say we wanted to plug in, is negative 3 over 2. So I plug that in, and I would also get 0. So now I found my 3 solutions. X is going to equal 2, 3 over 2, and negative 3 over 2. So when it's in standard form, I can either factor it if there's no constant, or if I just know how to factor it, okay? Or I can make my list, plug in or synthetic division, making sure that I get a remainder of 0, and I need to make sure that I know how many solutions I'm looking for from the beginning.